Hi, my name is Jerry, co-founder and CEO of LlamaIndex,
Hey, my name is Amog. I'm one of the Ray developers here at Anyscale.
and we're super excited today to present how LlamaIndex and Ray can help you build an advanced query engine over your data with LLMs.
So first, Jerry's going to give some context of how to build LLM applications.
LLMs are a phenomenal piece of technology for knowledge generation and reasoning, but the main problem is that they're pre-trained on large amounts of publicly available data. And so they don't inherently know anything about you yourself as the user or an organization. But they're so good at a variety of different tasks, from question answering, text summarization, even agent-like interactions like planning and using different types of plugins and tools. The main challenge here is figuring out how do you actually incorporate all your private sources of information, whether you're an individual or an enterprise, into your LLM application. This could include all different types of data, from file formats like PDFs, PowerPoints, documents, all the way to APIs that you commonly use, like a Slack or Notion, all the way to databases within your enterprise data lake. LlamaIndex gives you the tools to actually solve this and manage and query your data within your LLM app. It provides a comprehensive set of tools to index and ingest your data, as well as provide an advanced query interface within your LLM application. The first challenge that you must solve if you're trying to incorporate private sources of data into your LLM app is figuring out how do you actually load this data and how do you actually structure it in the right format so that the LLM can understand it. So to this end, we offer our data connectors as well as our data indexing modules. Our data connectors are offered through our site called Llama Hub, which offers over 100 different data loaders from a ton of different sources, from different file formats to databases to workplace apps. And this allows you to easily load in data from different types of data sources into your LLM application into a centralized document object. The next component here is being able to define the right data structures over this data. Data parsing, structuring, and indexing is essential because it allows you to define the units of computation and data that the LLM will eventually operate over. And so this includes, for instance, being able to parse a document into chunks of nodes. This includes being able to define indexes on these nodes as well, for instance, via keywords or embeddings, and then putting it into a downstream storage solution like a vector database or a document store. The second challenge that you need to solve when building an LLM application over your data is figuring out how the LLM is able to retrieve this data through the indexes that you created, as well as synthesize a response, and how to make this interface general enough to satisfy all different types of queries that you might want to run over this data. So this could include very simple questions that you want to ask over specific facts. This could include summarization queries, and this could also include complex multi-step questions.
So as Jerry mentioned, LlamaIndex provides excellent abstractions for solving two challenges with developing LLM applications. The first is during the data ingestion. With LlamaIndex, you can easily load files from a variety of different data sources, parse them, generate embeddings, and store those embeddings into a vector store. However, when you want to scale this process up to thousands or millions of documents, it becomes a challenge. This is where Ray comes in. By using Ray to parallelize this data ingestion process, you can quickly ingest and generate embeddings for many different documents from a variety of different sources, all in a much more performant fashion. Now, the second part of the LLM application is the actual querying. So once we've created these vector stores, you have an LLM which can access information from these vector stores and answer user questions, for example. So again, LlamaIndex provides the abstraction for being able to create these types of query engines. So given user input, you can use a LlamaIndex query engine to get some answer to your question. But when you actually want to deploy these types of applications in production, you need a good solution. And this is where RayServe comes in. Using RayServe, we can deploy our application, be able to request it, and be able to handle lots of different user loads through RayServe's auto-scaling. So with the RayServe, you get automatic load balancing and auto-scaling and a variety of other production features that are necessary for building LLM applications.
So let's take a look at an example use case where we can actually compare and contrast the Ray documentation itself and also the Ray blogs. And we can compare and contrast how these two different data sources present RayServe itself as a technology. So this is a complex question containing multiple steps. And the LLM query engine that we defined in LlamaIndex is able to first break down this complex question into two subcomponents. How does the Ray docs present RayServe? And then how does the Ray blogs present RayServe? It is then able to execute these sub-questions according to their corresponding tools or subquery engines. And so these query engines actually correspond to indexes defined over each document itself, or each collection of documents. So we have a collection of documents representing the Ray documentation. We also have another collection of documents representing the Ray blogs, and we have indexes defined over both. After we ask these sub-questions over these different collections of documents, we can get back some initial answers. The Ray docs present Ray serve as, and then you get an answer. And also the Ray blog presents Ray serve as a framework for it, and then you get back an answer from the Ray blogs. After you get back the sub answers to these sub questions over these different data sources, you can now synthesize this into a final response to present to the user that actually answers the original question. And the high level idea here is that the query engine abstraction within LlamaIndex actually allows you to define advanced interactions such as this query decomposition over different document sources and multi-step interaction between a retrieval model as well as the LLM to synthesize a response to a task at hand.
Okay, so now let's take a look at what this example looks like in action. I'll be running this on the Anyscale platform, but you could also do this full example on open source only. You can take a look at the blog post as well as a public repo for the full details of the example. So as we talked about, the first step in this process is how we can take our two data sources, the Ray documentation and the Anyscale blog post, and then create a pipeline to load those documents, parse them, generate embeddings for them, and store those embeddings into a vector store. So we have a simple script for that, where we're using the LlamaIndex parsing as well as embedding abstractions, and then using Ray datasets to scale out this process. So we define some few functions to load and parse the files, convert those documents into LlamaIndex node abstractions, and then use a local Hugging Face model to generate embeddings for these documents. And then finally, what we can do is then stitch together all this logic using Ray datasets. And by doing this, we can scale out the whole processing computation across the resources, the CPUs and the GPUs of our cluster. And this allows us to parse all the documents in parallel for much better performance. Once we do that, we can store the Ray documentation embeddings into a vector store. And then we want to repeat the same steps for the Anyscale blogs. So we, again, stitch together all the logic and then persist the Anyscale blog vector store on our cluster. So I can run this, and as you can see, it'll start churning away at our docs. Cool. And as you can see, we're making progress on parsing and creating embeddings for our documentation. Okay, so now that we have embedded both our documentation and blog posts and stored them into vector stores, now let's see how we can create our LLM application. So again, we use both LlamaIndex and Ray. LlamaIndex provides the abstractions for defining our query engines. And in particular here, we're using Ray serve to create our deployment that we can then query later. So if we take a look at this, we have two different query engines, one for the Ray documentation and one for the blog post. And then we also create a third query engine, which, as we showed earlier, is a sub-question query engine. And this one can intelligently come up with sub-questions that you want to ask for each data source. So this is all done via LlamaIndex. And then finally, we wrap everything in a serve deployment. And to actually run this, what we can do is deploy this application. So this will create replicas consisting of our application. And once this is started, then we can now query this to get responses. Okay, so now that we've deployed our RayServe application successfully, we can now query it. So we have this query script, which will send it a request. We'll tell it to use a sub-question query engine. And then let's ask it to compare and contrast how the Ray docs and Ray blog posts present RayServe. This will then generate two sub-questions. So it's going to first ask the Ray docs engine, how does a Ray documentation present RayServe? Then get a response. Then it's going to ask the blogs engine, how does a Ray blogs present RayServe, get a response. Then finally, it'll synthesize these two to provide some overall response. Also asked, so finished with one sub-question, now it's going to do the second one. Then finally, it will synthesize the response. And as you can see, we got the overall response, as well as the two sub-questions that were asked.
So in conclusion, there's four main challenges in being able to build an LLM application over your data. The first is being able to index over different data sources. The second is being able to create complex queries that act over these different data sources. The third is actually being able to scale indexing to a large array of documents. And the fourth is being able to actually deploy these production quality query engines to production.
And as we saw, LlamaIndex provides the abstractions to solve the first two and how you can index from different data sources and be able to build query engines to handle complex queries. And Ray, in particular, Ray datasets can help scaling out the ingestion pipeline, and Ray Serve can help deploying your LLM application in production.
Thanks so much for coming. And if you want to learn more, please check out the blog, as well as if you want to learn more about LlamaIndex, please check out our GitHub and docs.